The next topic is stoichiometric calculation. The stoichiometric means this the deals with the calculation of masses, sometimes volumes also. The reactants and the products involved in a chemical reaction. See how to calculate the amounts of the reactant is required and or the product is produced in a chemical reaction. That is called, already we were studied in lowest classes, that is balanced chemical equation, that is hit and trial method. See, consider the chemical equation. The CH4 gas, that is methane gas, react with 2O2 oxygen gas to produce carbon dioxide CO2 gas and water molecule 2H2O gas. Here look at this, all these are in gaseous form, both reactant and the product size. See here, now check whether the reaction is balanced or not. The number of carbon atom 1 from left hand side, the right hand side also 1, hydrogen atom 4, here also that 4 hydrogen atom, oxygen atom 4, 2 plus 2 4. Then totally for in this chemical reactions are balanced. Here we can calculate that methane react with this, so to form the carbon dioxide, and this we can tell that is 1 mole of methane react with 2 moles of oxygen and to gives 1 mole of carbon dioxide and 2 moles of water. So this whether you have to check whether there is no numbers, mean you have to tell 1, so that 1 mole. Here 2 are present. This is called the stoichiometric coefficient. The coefficient for the oxygen and the coefficient for the water. So this is called the stoichiometric coefficient. Then here the chemical equation we can tell that is 1 mole of methane gas react with 2 moles of oxygen gas to gives 1 mole of carbon dioxide gas and 2 moles of water gas. And other way, 1 molecule of methane gas reacts with 2 molecules of oxygen gas to give 1 molecule of carbon dioxide gas and 2 molecules of water, the product. Water gas is the product. Or we can tell by mass. Sometimes we can tell by volume. There is 2 possibilities also there. In case volume, suppose if I write 27.7 liter of methane gas react with 45.4 liter of oxygen gas to gives 22.7 liter of carbon dioxide gas and 45.5 liter of 4 liter of water gas. Or by mass means that is molecular mass. For methane has 16, so by mass means gram you have to use. 16 gram of methane gas react with oxygen that is O2 2 into 16 32. So 32 into 2, so this means plus 2 into 32, that is 2 into 32 gram. Then 2 into 32 gram of oxygen, carbon dioxide, that means CO2, carbon 12, oxygen 16 into 2 32 plus 12 44, so that 44 gram of carbon dioxide and water 18 is the mass number, 2 into 18 plus 2 into 18 gram of that water molecule gas. So this relationship, that is interconvertible. These data are interconvertible. That means mass to converts moles to converts the number of molecules. the same processes reverse also happen. So that's mean interconvertible. These are called stoichiometric calculation. Simply mass by volume is equal to density. Okay. Now let us see the numeric. That's mean based on this reaction, calculate the amount of water produced by the combustion of oxygen, 16 gram of the methane. That is combustion of 16 gram of methane. See, I will repeat that question. Calculate the amount of water gas, the states is very important, produced by the combustion of combustion of 16 gram of methane. Here the 16 gram of the methane, that means 1 mole, that is correspond to 1 mole, to gives what? Water molecule 2 moles of the water molecule gas. That is, so here there is 2 moles of water, that indicate 2 into 2 plus 16, right? That is mass of water, so 18. So 2 plus 16, it will become 36 gram. Suppose 1 mole of water, it's equal to what? 18 gram of, that is 18 gram of water, because 36 gram, 2 moles is 36 gram. It will become 18 divided by 1 is equal, that is 18 gram of water by divided by 1 mole of water. 18 gram of water divided by 1 mole of water is equal to 1. Okay, that's mean hence here the 2 moles of H2O, just 2 moles of H2O into this 18 divided by 18 gram of water divided by 1 mole of water. So it will become what? That is 2 moles means 2 into that. 2 into this is already what? 18. So that 2 into 18 is equal, that is 2 into 18 gram of this, you will be getting 36 gram of H2O. So this is the answer. Then how many moles, that is methanes, are required to produce, that is 22 gram of the carbon dioxide gas after combustion means we can calculate this also. That is here the 44 grams given, that is the 44 gram of carbon dioxide obtained from the 16 gram of the methane. So that is 22 gram of carbon dioxide, moles of carbon dioxide, that is 22 gram of carbon dioxide, then carbon dioxide gas into, that is 1 mole of carbon dioxide gram divided by 44 gram is produced, that is 44 gram of carbon dioxide gas. So it will become what? 1 divided by 44, that is 22 divided by 44, so that it will become 0.5 mole of carbon dioxide gas. Okay. Limiting reagent. What is mean by that limiting reagent? Sometimes the reactions are carried out when the reactants are not present in the amounts as required by the balanced chemical reaction. That means that in situation one reactant is an excess over the other. So the reactant which is present in the lesser amount get consumed after some time, and after that no further reaction takes place. So the amount of the reaction that reactant presents, So the reactant which gets consumed, so this type of reaction is called, that is amount of product formed, and it's called limiting reagent.